Howdy, you electromagnetic beings on this polymetallic nodule in space called Earth. This is this will be a pretty long video, I think. A heavy hitter, so to say. And let's start off with a few words from Immanuel Velikovsky, because we are going to talk about Venus and stuff like that. And as always, I will put links below. If you don't understand what he's saying, you can watch it again with the text on. But now let's give it a go and a listen.
Velikovsky contends that global catastrophes have occurred throughout the geological history of the Earth, and that these catastrophes have been caused by agents external to the Earth. The most recent catastrophes were caused by Venus and Mars. These agents can be identified through the ancient scientific and literary writings. In 1950, when Velikovsky published Worlds in Collision, it was assumed and widely believed that all of the planets were formed on the order of several billion years ago, all formed at one time. It was also assumed and widely believed that no global catastrophes had occurred on the Earth since its formation. Several review articles appeared in magazines before the book was actually on sale to the public. And from these review articles, it was quite obvious that Velikovsky did not make these assumptions. Hence, he was considered to be incorrect. The assumptions by 1950 had become scientific dogmas, and the astronomers and geologists of the time considered that no amount of proof could disprove these assumptions.
Well, what's happened since 1950? Do the people who objected then still object?
The people that had vested interest in particular theories at that time are still quite violently opposed to Velikovsky. It turns out that nearly every major unexpected find in the space age was expected by Velikovsky and people who had read his works.
And what is the main objection to Velikovsky?
Astronomers usually find out that Velikovsky contends that Venus erupted from the planet Jupiter and assume that that is totally impossible and hence write off the entire theory. Then if somebody comes up and asks them, what about Velikovsky's work? They say, no, it's totally wrong. And this is one of the main reasons that they give.
What are a couple examples of some of the predictions that have come true?
A prediction that actually Velikovsky prefers the word advanced claim was about the temperature of Venus. It was not considered that Venus was as hot as Velikovsky claimed. But by 1962, when the probes went by Venus, it turns out that Venus was extremely hot and much hotter than anyone except Velikovsky had anticipated.
What will happen if Velikovsky is given credit for some of these predictions that have been proved? What effect might all this have?
If people start investigating his works open-mindedly, and hence they will start realizing that there is considerable logic behind what he says, this eventually will require new textbooks in astronomy, history, geology, archaeology, and all related fields.
All right, so let's go on with the theme of Venus, because it is rather an up-to-date theme. Because if we go over to spaceweather.com and go to the Thursday of 15th, we can read that a blue flash from Venus. Italian photographer Paolo Palma was watching Venus sink into the sunset on August 12th when something extraordinary happened. A piece of the planet broke away and turned blue. That's amazing. Amazing footage. This is a very rare blue flash from Venus. You've heard of green flashes. They're sometimes seen when the sun is setting at sea. Temperature inversions and strong thermal gradients in air above the sea surface split the sun into RGB colors and magnify the green into a dramatic flash above the setting sun. Blue flashes are formed in the same way as green flashes. However, blue flashes are harder to see because air molecules and aerosols scatter blue light. When the air is exceptionally clear, however, the blue flash emerges. Photographers are lucky when they catch a blue flash from the sun. Catching one from Venus is a once-in-a-lifetime shot. Congratulations, Paolo. Yeah, he did a very great work. But I have been thinking about this since we know that Venus's atmosphere contains very much sulfur, and I am intrigued with sulfur since a while. And when you go over to my Finnish copper playlist, then you will find, for example, this one. So that's the video. That's the basic experiment, just putting a pebble into a microwave and see what happens. And obviously there's something going on. But I don't want to bore you too much with this, so let's go to the end, because we are still talking about Venus. And the thing is, you have to understand there is a whole lot of smoke going on and stuff like that during this experiment. And the smell, yeah, it's sulfur. It's burning sulfur. And sulfur burns with a blue flame. So I heated a pebble in my microwave that obviously had a great amount of sulfur within it, to such an extent that the sulfur started to burn, and there was this liquid that emerges from, or with, that is left afterwards, dark red, sometimes even black. Yes, it was sulfur. So I was just thinking, if the blue flash from Venus was actually burning sulfur, because there has been quite much solar activity, and if there would have been some very strongly induced currents or something like that, and it just burned some of the sulfur, and it burned with a blue flame. You know, that's why we had a blue flash from Venus. I don't know. This was the first thing that came to my mind as I was reading about that, and it was very interesting. So now, since we are talking about Venus and sulfur, I want to show you a few pebbles, and afterwards I'm going to show you some auroras. And yeah, let's check out some stones I found recently. For example, this one. That's sulfur. And the funny thing is, like, I found this almost at the same time as they found sulfur on Mars. And here on this side, I heated it up and it smelled to sulfur and it turned red as sulfur does after it gets heated up. And then I cut it open. And you can see there is yellow, which quite likely is sulfur. There might be iron in that too, probably other materials as well, but sulfur. It is going through the stone. And we have rather big crystals here. Let me show you that here. That's the same area which was very visible in the first picture I showed from that stone. And you can see it's going through the stone throughout the whole, not the whole pebble, but in a rather big area. And down here, there's a yellow area too. This one I found today. And these holes, inclusions, or however you want to call them, they are very interesting. And it has a flat bottom. For those who know or have seen Andrew Hall's video about the pebbles with the flat bottoms, I recommend you to go to check it out. Anyway, that's the place where I found it. So I cut it open. And that's amazing. That's really amazing. That's not the best picture quality. But obviously you can see that there's layering going on. We have many different layers going on here. And that's the smaller part, or the smaller side of it. And the other side, in a way, blew my mind, because first when I cut them open, you don't see really what's inside. I noticed that it's dark, which was already very interesting, because to me it's another yet brimstone I found. And I noticed that there is this obvious layer, because it's dark, but I haven't seen the big metal flakes in this, because it was, dry and just cut open and stuff. And after grinding, I just grinded it for a while without really watching, because I wanted to have the surprise factor. I just didn't really watch, so I just grinded and grinded. And when I took a look at the other side of this pebble, I was like, what? Are you kidding? Because not only does it seem that there is an A, which is very funny, because I still haven't found a number, but I found an A in a stone. But we have also a hexagonal shape out here. So after working through, like, I got some of the stones, and I just worked all the stones through to all the stages of the sandpaper. When I noticed this one, I thought, you must be kidding. this can't be true. But obviously it is. And it's a brimstone. And we have amazing layering. We have even layering on a smaller scale. And there is metal, probably different kinds of metals. And then is the next question that what's the origin of this pebble? Because according to common geology, it's said that sulfur is produced by some microorganisms at the bottom of the lakes. Yeah, there might be something like this going on. But I have found these kind of pebbles on top of the dunes here, and many of them exhibit very strong metamorphical patterns. Let's see if we have something like this here. Probably this could be something like a shock wave. That's the shock wave, the line itself. If it's so, but that's maybe the easiest thing to spot in many other pebbles. I'm gonna show you in a moment shockwave patterns in a pebble, of which I am very sure, yeah, it's very much said, but I'm very sure that they are shockwave patterns. So this is probably one of the most amazing stones I've ever found. There's a hexagon and an A. Not a number, it's a letter. Then we have the basic suspects, the green stones, they're all over the place. I really like this pattern here. And we have metal inclusions. This bright part here, all the black stuff you see here is basically the same crystals. Maybe that's stromatolite. I just wanted to show you in a certain angle that these are very shiny. Like all those black, like these big pieces here, if you watch it from the correct angle, they will reflect light. And I think they could be also very conductive. And I also think that in order to produce them, you need a whole lot of heat and pressure and stuff like that. Rather wild circumstances. Very bad weather. And here, you see the bright things? These are all metal flakes. Very tiny metal flakes, shiny. And then we have the black, which could be graphite maybe, or something like that. Then we have a layer. And we have quartz that has also metal inclusions. They are all over the place. Different sized grains of quartz, and there is more metal and maybe this kind of coal related material. And there is quite a lot of sulfur also in this pebble. And here we probably have some shockwave pattern as well. So if you compare this setup to a battery or whatever accu you use in your phone or whatever, and you would submerge this kind of material into water somewhere deep where we have salt water or something, and the water would penetrate through the rock in the pressure, we could probably imagine that if the circumstances are correct, there could be some kind of an energy exchange going on just between those two layers in this little one pebble. It would function basically as a battery in a way on itself, and it would also therefore would exhibit own electromagnetic fields that in further or like suitable circumstances could attract other things magnetically, in simple terms. Or also chemicals, chemical compounds like oxygen or other like acids or whatever you want to call it. Material from the surroundings, they will get attracted to other materials in the surroundings. And if the electromagnetic properties of the environment changes, some materials, if they get heated up to a certain extent, they lose their magnetic properties, for example. Other things, if they get heated up, they start to conduct very well electricity, for example. If we just think about clouds, basic clouds, what you have outside, they are basically, in a way, the magnetic expression of the electromagnetic field of the Earth because they are horizontal and not vertical, not as the auroras, which are vertical, but I'm going to show you this later. So, we could think that there would be stuff sticking to a battery like this, especially if we have all these different kinds of layers. They could, in a way, all amplify each other. Like this one here, you have all kinds of stuff that is sticking to that stone on the outside. And on the inside, obviously you can see it's not yet finished with grinding. Because that's very hard, in a way. It's a hard stone. But you can see already the layering all over the place. Darker and brighter areas. And I think there are many, 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 many small metal flakes in that stone as well. Yeah, once when I get it done, I have to show you that again. So this could be just one example for how we can find these batteries in nature all over the place. You don't have to dig it from the deep sea floor. So now let's go to the auroras because we had some geomagnetic storm activity recently. And yeah, I was outside, not from the beginning, but almost till the end. Actually not, because I forgot about the shockwave pattern. I still have to show you this. That. I think this is a shockwave pattern that got created at the moment that stone got created. So that's just a slice of a rather big pebble I found some time ago. This one. Yeah, that's a rather big one to carry home in a pocket because it's much bigger than my hand, for example. But I think this is a very good example for metamorphic processes being rather violent and quick because they have to fuse together almost instantaneously. And this goes through the whole stone, this line. There's a black line going through the stone. And there are other interference shockwave patterns, I think, here to this line, because they are all in the same angle. It might be crystalline in nature as well, but they are continuing at some parts. And here up we have yet another example of a shockwave pattern in a small scale. This is what I think. Yeah, so it's very easily visible with bare eyes. It's just there. But now let's have a look at some auroras. Yeah, there has been some talk about orange and auroras, and yeah, I am very pleased with the quality of the pictures, and these are handheld. I didn't really expect it to be able to capture these kinds of shots. I'm very pleased because with bare eyes you couldn't see not the half of the whole thing. There are some dark features in some places. I think there are clouds, and this is looking basically straight up. Yeah, this would come over better if you would turn the screen 90 degrees. And there's like lower or auroras as well. If they are lower, I don't know. Here we have a nice wavy pattern and rather dark violet colors there in the background. And this is one of the pictures I like, because above my head, as you can see, it's like green. And this was rather bright, the green above the head. But these faint ones, this was barely visible with bare eyes, maybe this one too, but all the others here, and also not the color here, it wasn't visible with bare eyes. So you just took a picture and then you would look at the picture and you, whoa, I was very surprised, very pleased. This was straight up, and I really liked these. What are they? Tendrils? Expression of the Earth's vertical electric field? Yeah, not the sharpest picture. Some of the pictures aren't the sharpest. Yeah, that's straight up. And this was very intense in brightness. Yeah, these I found interesting. I have never seen clouds somehow in front of the auroras. Yeah, and then it again intensified, and sometimes it was difficult to know in which direction to watch. Straight up was sometimes very interesting. And I also managed to get some time-lapse videos. Now finally, after several days, I think I managed to be able to watch them by myself and also share them with someone who's interested in these kinds of things, because I think probably there is something odd. Yeah, but I'm gonna show you later. These structures are very, very interesting. And also here, it's rather faint, but there are auroras, and there's the color. Yeah, we were watching. Yeah, not the sharpest picture. And there was 1,000 mosquitoes. And it got rather cold. And this was basically to the wrong direction. In this direction, I really couldn't see auroras. And as you can see, there's a light in the background because there's some industrial facility. But it still captured some of the northern lights up there. And I don't know, do we see orange here? Is there some orange color? Because there has been some talk about orange. Rather intense colors in this as well. Yeah. Don't look up. Yes, we do. Yeah, I thought that's also interesting because it wasn't really visible with bare eyes, but the colors, like that's a rather deep red, violet, I don't know, purple. And here in the background we have clouds in front of the aurora. Or at least it looks like that. I don't know. That's in a way strange. I have been writing about the auroras touching the ground and stuff like that, aurora precipitation, the origin of the copper and sulfur being from somewhere else than Earth, for example, Venus. And then very strong auroral discharge events and the auroras touching the ground. Maybe Earth received the sulfur and the copper. And many of those polymetallic nodules got formed in the same event or in the same kinds of events. Very dark red auroras there on the left side. And I think I couldn't see them with bare eyes. I'm not too sure. But that's very intense color. And in a way, it seems to go very low as well. This might be just an optical illusion. I'm very aware of this. But we are not done yet. Hopefully, you're not bored. This is looking straight up at the edge of where the auroras end, and you can see the universe again. Yeah, that's just amazing. It's just amazing. I also find it very interesting that we have this rather strong contrast of darker color just below of where the auroras stop. And I don't know if these are clouds. In a way it looks like. And also the colors of the auroras itself. Here we have almost white. White auroras. Yeah. Seems to be white in a way. What to do? And that's also rather white in a way, I would say. Yeah, I don't know. Does it make sense? Would it make sense to say all the time something you just can watch and be in awe? There's again very dark red in the sky. Yeah, I think this is the one that reminded me in a way of a Berkman current that comes down to Earth. And it looks like, yeah, that's the same thing. That looks intense. And it has, in a way, a spiral shape. And I don't know if there's some brighter spot going on. Maybe that's just some industrial facility. Yeah, the whole sky is lit up. Like there's purple all over the place and red. Yeah, there's still a few pictures of that, and then we will take a look at some time-lapse videos. But there's still something very interesting at the end of this photo sequence about the auroras. There we get this kind of an arc, which is not that uncommon, but I think, or to me, the colors, they are very interesting. And then it intensified. I think this was the last intensification after it either went down with intensity in general or the light just got too much in order to make it shown. I think, yeah, this. Yeah, I guess you know what I mean. This was very bright, or got very bright. That's still to the other direction. Yeah, look at that. This was very bright. And it seems that there is some clouds. And if there are clouds and this is going below the clouds, then we might deal with something even more interesting. And what's up with this strange structure thing? Is this just the grainicity of the camera? I don't know. What are we looking at exactly? I don't know. Camera bug. But obviously, as you can see, this is now a wider screen. So the picture quality is less. And we have more structure in that. So this structure here might be just more related to the camera. But all in all, I think it's very interesting to have this kind of. These are the interesting structures. This one. This looks to me very intense. So now that's one of the time lapse I managed to get from the auroras. Yeah, it's the first time I did something like this. So not only took it a while in order for me to get a grip of those and I actually can take a look at them, which happened today. But also, as you can see here, the forest isn't sharp. So the whole picture isn't too sharp. And this is shot in vertical position of the with the camera in order to get more height, obviously. So now let's just have a look at that time lapse. So they are rather consistent. There has been a lightning. Oh, no, not lightning. Parasite. Yes, I got it. Now let's continue. Yeah, but there's some pulsating going on. Check it out. If you look down here, no, it's actually up here. Here in this area, there's some brighter areas that appear rather quickly and dim out. There's some kind of a pulsation going on. That's sort of interesting. They are very quick. Now it's bright. No. Now it's bright, so to say. And if you go on just a little bit, the same area, it gets dark again. So now let's have a look at the whole thing again from the beginning. Yeah, that's rather neat. Would be even more neat if it would be sharp. But it was very difficult somehow to get it. To get it actually sharp. And I tried to take the forest as a parameter for sharpness. That's another time lapse I made. And due to the unsharpness, we probably could see this thing better, which is maybe the same thing I showed you earlier on the photograph. But I want you to compare the activity that is going on here about the vertical lines. Here we have one of those two and they're all over the place, and how they are moving down here. And compare it to the activity that's going on here. Because here we have, here in this area, it's flickering. Flickering. Look at that. When I noticed this the first time, I thought that's some camera glitch. What's going on there? Compare this area to this area. The ones on the right are just wobbling around as normal, and the ones on the left are jumping. What's going on? And it doesn't seem to me that there would be something wrong with the camera. And obviously, you cannot see this flickering with a photograph. I don't think that they should do like that. This is yet another time lapse straight above the head. And I think I will end this video with another. There's still one time lapse to come with the clouds that are moving in different directions. And just enjoy, look, and I will shut up. Thanks. Bye. Yeah, Noctilus and clouds.